In 1831, Faraday discovered electromagnetic induction and designed the homopolar generator, which consisted of a copper disc that spun in a magnetic field. Now, the same principle of induction can be seen in modern-day dynamos and generators. And I'm going to show you how to build a simple hand-cranked generator that uses everyday components, including magnets, 2 of them, a nail, some copper insulated wire, some electrical connectors, 2 pennies, some black insulation tape, and some cardboard. The first thing to build is the frame within which the nail and the magnets will spin. Now, it's really important that you use strong cardboard here. If your cardboard that you use is too soft, there's a good chance that it will collapse under the pressure of the copper wire. So try and get hold of some reinforced cardboard. So using your magnet as a guide, I placed it on the cardboard and made sure that I have space either side of the magnet, so I know that the copper wires won't touch the magnet when we build the generator. Cut a strip of cardboard. So now we have a strip of cardboard, and this is going to make up the frame going around the magnets. Take a magnet, place it horizontally on the cardboard strip, and using a pen make some marks either side, approximately where you want the folds to go. Cut just into the cardboard, scoring down halfway through the cardboard to create a fold line, which I can now fold and fold. Make the hole next where the nail is going to go through. So we're going to go corner to corner with a straight ruler, which will give us the exact centre. And take the nail, push it through the cardboard. Now, it's important to make this hole a little bit bigger so the nail can turn easily, freely, with no resistance. So keep pushing the nail through several times until the hole is a bit bigger. It's really important that the cardboard is built around the magnets so that the magnets are free to turn. You've got to try and have it as square as possible. If the frame is at a skew like that, then the magnets won't be able to turn. And that is really the reason why one width of cardboard is slightly smaller than the other side. This one here is bigger, so when the cardboard folds round, this piece of cardboard fits nicely inside. So here, what I've done is I've just marked out the 2 sides. This side here, 1, 2, 3, 4, 5, is slightly smaller than this side here. 1, 2, 3, 4, 5, 6. I'm now going to score those just as I did a few moments ago, and then carefully fold them over like so, and there we have a nice strong rectangle cardboard frame. You've then got to push the nail through the existing hole and create a new hole the other side. Now, this is pretty hard work. Okay. So now if I put the nail through, I can spin it freely. Perfect. You have to be careful with magnets, because if they're very strong magnets, then you can get your fingers trapped. So carefully place the magnets on the nail like so. You'll notice that there are gaps because the nail has a thickness, and what I tend to use just to help fill those gaps is a penny either side like so, and also get a little piece of sticky black insulation tape which you can wind around the magnets. It will help keep them together when they're spinning. And you have now got magnets spinning freely and fast inside the cardboard frame. Now the next stage takes a little bit of time. You're going to need the insulated copper wire. Now this has been insulated on the outside with enamel. We're going to wind this wire around the frame. Now we have to be careful that we have to leave a nice long piece at the beginning, so what I tend to do is I tend to wind it just around the end of the nail, and we'll use that bit later on. And then we're going to start winding it carefully around the cardboard. Make sure you do not pull so tight that the cardboard starts to bow in, because the pressure of 300 windings will eventually squash the cardboard. So be very careful not to over tighten the wire, just carefully wind it round 300 times. 200 times will produce a voltage, but 300 times is best. If you should be able to produce something like 1.5 volts. So here we go. That's about 10, 11, 12, 13, 14, 15, 16, 296, 97, 98, 99, 300. So that's it. 300 winds of the copper wire. What I've done is I've put a piece of black sticky tape to make sure the wire doesn't come unwound, and I've connected one end of the copper wire to this red connecting cable and the other end of the copper wire to the black connecting cable. So now we're in a position to connect it up to the voltmeter and see if we can make some electricity. First of all, I'm going to connect the connectors to this bridge rectifier. And from the other end of the bridge rectifier, it goes to the voltmeter. Hopefully now, the faster I turn the nail, the quicker the magnets will turn, the more electricity it will produce. Here we go. There we are, 1 volt. I just managed to reach 1 volt of electricity. So there you have it, a small hand crank generator. The faster I spin the magnets, the more electricity it produces.